Hello and welcome to another session in mathematics. In this session we'll be looking at statistical graph, just like we've been dealing with statistical graph or this Y. But our focus today will be on histogram. Okay, but before we go on, let us take a review of our previous lesson. Welcome back. In this class today we'll focus on histogram and the mode of grouped data. The formula we use in finding mode of grouped data. Okay, let's start. A histogram is another way frequency distribution can be represented graphically. It consists a number of rectangles, and in plotting the graph of a histogram, the class boundaries are on the horizontal axis, that is the x-axis. The class boundaries are on the x-axis, while the frequencies are on the vertical axis, which is the y-axis. So the class boundary are on the x-axis while the frequencies are on the y-axis. Then we plot with the upper class boundaries against their corresponding frequencies. Okay, the histogram differ from the bar chart because histogram is used for grouped data. We use histogram in a grouped data. The bars overlap. Okay, they are not separated from each other, they overlap. Okay, that's how the histogram looks like. Okay, there is no gap between two or more bars. Okay, so let us quickly take an example and then we explain that better. Okay, let's go. We have a question here on the screen. The table below shows the weight distribution of 40 pupils in a school. We have weight in kilogram, 41 to 45, number of pupils 3, 46 to 50 we have 7 pupils, 51 to 55 we have 12 pupils, 56 to 60 we have 10, 61 to 65 we have 6 pupils, and 66 to 70 we have 2 pupils. Then we have 3 questions here. A, draw the histogram of the distribution. Draw the histogram of the distribution. B, find the modal class. Find the modal class. Then C, from your histogram, estimate the modal weight of the distribution correct to 1 decimal place. Find the modal weight. So we should estimate the modal weight of the distribution. Okay, let us start with A. The first thing we need to do, solution, is to prepare our class boundary. How do we do that? We have our weight, which is in kg. We have our number of pupils, and then we have class boundaries. I hope we still remember how to determine class boundaries. Under the weight, let's go back. We have 41 to 45, 41 to 45, have 46 to 50, 51 to 55, 56 to 60, we have 61 to 65, and then 66 to 70. That's the last, I think so. Yeah, 66 to 70. Okay, for their numbers we have 3, 7. We have this to be 3. This is 7. This is 12. This is 10. This is 6, and this is 2. Fine. Then the next thing is to find the class boundary. I told you that what to do to the class boundaries is to add minus 0.5 to each and every one of them. So you have 41 minus 0.5 minus 45 minus 0.5. Okay, if you do that, you have 41 minus 0.5, then minus 45 minus 0.5, and that will give you what? That will give you what? 40.5 minus 40.5 to 45.5. Okay, do the same here. You have 45.5 to 50.5. Same here, you have 50.5 minus 55.5. Do the same here. 55.5 minus 60.5. 60.5 minus 65.5, and this will give us 65.5 to 70.5. These are the class boundaries. So we now have to plot this graph, okay, applying the condition we are given here. It said the class boundaries are on the what? On the x-axis. The class boundaries are on the x-axis, while the frequencies are on the what? On the y-axis. So let us plot that. We have a line, okay. This is our y-axis, this is our x-axis, okay, and we are okay. There's no zero here as long as the histogram is concerned. There's no use of what? Zero. And we have our y-axis. This is our y, okay, to be 3, 7, 12, 10, 16 and 12. So we add the numbers. Let's use 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, now for weight 45 to 40, 41 to 45, we have the class boundary to be what? 40 to 40, 40.5 to 45.5, and the length is what? Is 3. So 3 will be in between 4 and what? 2, and this point is what? 40.5, while this point is 45.5. Do you understand? Okay, that's how we do that. Then secondly, we have 45.5 to what? 50.5, and the number here is what? Is 7. So we draw this up from here. Remember I told you that you don't separate the both of them. 7 will be at the center of 8 and 6. You draw it down. This point is 50.5. 50.5. Okay, then we have the next one, which is 55.12, 55.5, which stopped at what? 12. Okay, we move from here, and this is our 12. We'll draw down, and we'll have that to be what? 55.5. So here is 55.5. okay. The next thing we have is 10, and it's 60.5. 10, this is 10 here. 60.5. okay. The next one is what? Is 6 and 65.5. This is 6 here. Draw down. 65.5. And then the last one is 2, and that is 70.5. 2, and this is our 2 here. 70.5. okay, this is what the the histogram looks like. Now we've succeeded in answering the A part of this question that said we should draw what? The histogram. And then the B part of it said we should find what? The modal class. Find the modal class. So what's the modal class? From the table and the graph. The modal class is the class boundaries with the highest frequency. The class boundaries with the highest frequency. And remember, this is our class boundaries. And here is our what? Frequency. Okay. Now he said the class boundaries with the highest frequency is what we call what? The modal class. Now looking at this, this is the highest frequency here, and the class boundary is 50.5 to 55.5. okay, that is the modal class. Do we understand? Okay, then C part of the question said we should estimate the modal weight of the distribution. The modal weight of the distribution. Okay, we should estimate the modal weight. How do we do that? What we do is to draw a line to here, and then draw a line to this. Okay, and then trace this line from here downwards, this intersection. Trace it down. Remember, you were supposed to draw this with a graph. Okay, now when you trace it down, the point where it stops is the estimate. Okay, looking at this, this is 55. So let's assume that the point here is let's say 53.98, and then the question said we should correct it to 1 decimal place. So our answer then will then be equal to 54 kilogram. Okay, now I want to show us another way of finding the mode of a grouped data. Okay, so let us do that. We have mode of a group data to be equal to L1 plus C into FM minus FB all over 2FM minus FB minus FA, where L1 is lower class boundaries of modal class. I want you to note these things. Then our FM is frequency modal class. That's what FM is. Then our C is class size. Remember how we can obtain that? It's upper class minus lower class boundary. That's how we obtain that. Then our FB is equal to frequency of class just before modal class, where our FA is equal to frequency of class just after modal class. Okay, these things are important to know all their meanings. So I want to illustrate the use of this formula with the example we just solved now. I said we should find the modal class. Okay, so let us apply this now. let us apply this now. I told us that mode is equal to L1 plus C into Fm minus Fb all over 2Fm minus Fb minus Fa. Now, from the question that we solved, our L1, I told us, is what? Lower class boundary of what? Modal class. Lower class boundary of modal class. Is that correct? Now, from this table, common sense will tell you that 12 has what? The highest frequency. Is that correct? So this is the lower class boundary. This is the lower class boundary. So our L1 is equal to what? 50.5. Okay, we'll come back. We talk of our C. Our C is class size, which I told us that it is what? Upper class minus lower class boundary. Upper class minus lower class boundary. So we have 55.5 minus what? 50.5. Our C is equal to 55.5 minus 50.5, and that will give us what? 5. We've gotten the value of C. Let's still go back. Then we'll talk of our FB frequency just before. I said that FB is frequency just before what? The modal class. This is the frequency before the modal class. The frequency before the modal class, which is what? 7. So our FB is equal to what? 7, which I told us is the frequency of class just before what? The modal class. Now we've gotten the value of FB. Okay, let's get the value of FA. That is FA, I told us, is the frequency of class just after the modal class. After the modal class, this is the modal class. After the modal class, we have what? We have 10. So our FA is equal to what? 10. Are we following? Fine. We've now gotten all the values required. We've gotten all the values required. Our FM is the frequency of what? Modal mark. Frequency of modal class. This is the frequency, which is 12. So our FM is equal to 12. We then apply it in this what? Formula. We have L1 plus C into Fm minus Fb, Fm minus Fb all over 2Fm minus 2Fm minus Fb minus Fa. Okay, so our L1 from this is 50.5. We have 50.5 plus C, and our C is what? 5. We have 5. Open a bracket. What's our FM? Our FM is 12, and our FB is 7. So we have 12 minus 7 all over 2 times. What's our FM? 12 minus what? 7, which is our FB, minus FA. What's our FA? 10 minus 10. Okay, so what do we have? We have 50.5 plus 5 into 12 minus 7. What do we have? 12 minus 7 will give us what? 5 all over 2 times 12. 2 times 12 is 24. So we have 24 minus 7 minus 10. We have 50.5 plus 5 into 5 divided by 24 minus 17 will give us 7. Okay, now that will give us 50.5. so we have 5 divided by 7 times 5, and that will give us 3.57. okay, now 50.5 plus this will give us 54.07, which is equal to 54.1. okay, we'll stop here for today. But before we go, kindly provide the answer to the following questions on the screen to refresh your memory on what we've done so far. Welcome back. We've been able to cover histogram and the formula to find mode in grouped data. So we'll stop here today. In our next class, we'll continue. So feel free to use the lesson note on the platform for better information and understanding of what we've just done, and feel free to drop your comment on the comment section. Till we meet again in our next class, remember to stay safe and bye.